I'm just gonna continue on like the same thing I was talking about last week because I have a Chem 14C midterm coming up, and I think this would be a good way to study it because like this is something I just need to work on. So last time I talked about stereocenters and being able to identify what is stereocenters, and I just talked about like basic definitions a lot. And oh yeah, I'm not inside in the hallway because my roommate's asleep. But this time I'm gonna talk more about configuration. So there's a system so there's like two names or two ways you're supposed to name them. You either give them an R, like a molecule, you either give it an R or an S. Okay, a molecule, if it's a stereocenter, you give it an R or an S. So there's this method, there's a system, it's called the Kahn and Gold pre-log system. So basically what you do is that you first assign priorities to all the thing that's connected to your stereocenter, and then you rank them on priority, and then you go from highest to lowest priority, and if that rotates counterclockwise, it's an S. If it goes clockwise, then it's not. So I'm gonna basically just spend most of the time doing examples because my TA gave an example of this during class and actually helped me a lot. So I'm going to do an example with 2-chloral butane. So say it's example. Okay. That is 2-chloral butane. So first we need to assign priorities. So, okay, well first we need to identify the stereocenter. So see this dot right here that represents a carbon. That technically has four different things attached to it. It has the chlorine, the hydrogen, this, I think it's methane, ethane, and it has the methane. So basically, yeah, 4 different things attached to it. So now we have to rank on priority, and you rank based on the atomic number of what's exactly attached to it. So the atomic number. So technically, I'm going to redraw this. Technically, this is C, then H, Cl, CH3, and CH2CH3. Yep. So basically how you assign priority is that you don't add it up, you go based off of the highest atomic number. So that's directly attached. So we're going to start here. Directly attached is an H, this has like atomic number of 1, a carbon, 4, another carbon of 4, and a chlorine, which is a 7. Since 7 is higher than 1, 4, and 4, this is the highest priority. Now second highest priority. So we have these 2 carbons higher than this hydrogen.
Having like a small portion of the material you
Okay.
can
So this is going to be one of these 2 are going to be the 2. We don't know which one, and we're going to figure out which one. Sorry that it's loud. I'm in the middle of the hallway. I'm actually right next to the oven. So what we have to do next, since these 2 carbons are the same, we have to look at the next thing that are attached. There's a hydrogen. It's also hydrogen. Same. Then after that would be another hydrogen. Same. Then after that it would be this carbon and the 3rd hydrogen. The carbon is greater than 3rd hydrogen. So this is going to be the 2nd highest, and then 3rd, and then the 4th. And then once you assign priorities, you're supposed to rotate the atom so that the lowest priority is in the back. And it's already like this. So like just swap this out, and then look at this. And then you see which order it goes, and it goes this way. And since it goes that way, it goes clockwise, right? So this is R, this is S, this matches the R. So this is a R2 chlorobutane.